And let's do our third question here. What is the probability of selecting someone from this population who got the drug or is alert? For this, we need the general disjunction rule. Okay, and we already used the special disjunction rule, and we used that when the values we were looking at were mutually exclusive. Here, the values are not mutually exclusive. So someone can have gotten the drug and be either alert or not alert. But it is possible to both have gotten the drug and be alert. Having one of these values does not exclude you from having the other. Okay, so the general disjunction rule then is this. Okay, the probability of A or B is the probability of A plus the probability of B minus, this is important to remember, the probability of A and B. Excuse me. So why we need this last term here, we'll talk about in a second, but first let's just do this for our problem. So okay, so the probability for selecting someone who's taking the drug is 0.60 plus the probability of selecting someone who is alert is 0.72. Probability of selecting someone who got the drug and is alert is what we just figured out here. Probability of drug and alert, we did that, so that's going to be 0.48. So we use that 0.48 right there, and that's going to give us 0.84. So there's an 84% chance of selecting someone who either got the drug or is alert or is both. Okay, 84% chance. So let me just quickly go over why we need to subtract out this term. I mean, one reason, or no, this is not really the reason, but you might notice that if we had just used these two values here, we would be over 100%. That would be 1.32, which is impossible. There can't be a 132% chance that we get someone who took the drug or is alert. We can't go over 100%. Okay, so I mean that alerts us, although it won't always be the case that these two values go over 100%. But more importantly, if we look at our diagram, I've already kind of drawn all over this thing, but if we think about what we're adding up the probability that someone is in this part of the population, that is the probability that they took the drug. So the probability that someone got the drug is the probability that they're here. And the probability that someone is alert is the probability that they're in this part of the population. You can, okay, so that's the probability that they're anywhere in these top two boxes. Okay, fine. So we're adding the probability of being in this column on the left and the probability of being in either of these two portions on the top. But you'll notice that means that this drug and alert, this guy right here, got counted twice. We counted this box right here, or we counted the probability of being in this part of the population once when we did the probability for getting the drug, and then second time when we did the probability for being alert. So we don't want to count this probability, the probability of being in this box twice, so that's what we need to subtract out. So that's what you're subtracting out here, and so that gives us the accurate probability. Okay, so again, we'll have another video that goes over the special conjunction rule, but You should read section 6.2, and you should use the exercises that are at the end of the chapter. Okay, that's a wrap.